Hi everybody, part 2 of FM21, because the bottom section, this is probably the part that was more confusing to you, so keep it separate. So in any case, we're here, and then we have a table of values. There's no equation here, so this is just like, well, what is this? Well, you can have a function that's defined as a table of values. It has inputs and it has defined outputs for each of these, so okay, fine. So when we compose these, what does it mean to have f of g of x, for example? Well, notice that I'm plugging g of x first into g of x. So with these function notation up here, and actually I'll emphasize it right here. Let's talk about fog actually while we're at it. Notice that I plug x into g and then the output from g into the f function there. So I work, the best way to think about these is inside out. I work from the inside to the outside of this thing. Now, if I circle, I don't like red, let's go to pink. If I circle fog right here, I don't like this notation as much, it looks foggier. But this simply indicates the same thing as f of g of x. So on SAT tests and other things, you might see the fog notation. Just be able to go back and forth between these things. Usually when I see one that is written like fog, I will rewrite it as f of g of x notation because this makes it really clear, again, that I'm plugging g of x into the f function. Okay, fine. So when I do this, if I'm looking back down here now, and I guess I should work in the in light blue or something like that. I'll work in blue. F of g of x, the first thing I'm going to evaluate down here is the g of x. So it's easiest to go over to this table right here, and where I put start here, and start there. Because when I'm doing f of g of x, the first thing I've got is this x value right here, 8. I plug it into g of x, I get a 1. Now I'm going to take that output value, g of x of 1, I'm going to plug it into the f function. And then I go back over here and I say, well, I better have a 1 defined here. And indeed, that 1 right here, when I plug 1 in, it yields an 8. And notice, I plugged an x value of 8 in, I got a 1 from g of x. G of x, the output of g of x was defined as an input to the f function. I got an 8. So notice the easiest way to do these things is actually go straight over to that table, the way this is written. And then the same thing with all the others. 13, I plug 13 in for x. I get a 0. 0 is also defined over here, and 0 yields a 13. 11 yields a 15, and 15 comes out with another 11 again. So an 8 gets plugged in and end up getting an 8 out after the whole process. 13 to 13, 11 to 11, 9 to 9. And as you get down to the end of this thing, you say, hey, that's what an inverse does. I plug x in, I get x out. You can also check it the other way around. Let's erase all that junk. So if I was going to do g of f of x, what color should I'll do it in green. G of f of x, well, let's just start over there at that table. Nah, I don't want to make it that high. When I go over here, I'll start a little g of f of x column over here, so I don't have to rewrite the whole table like I did here. The first thing I'm going to do is f of x. Okay, fine. Erase all that. Take 1. Start here. Start. Take 1. Plug it into f of x. You get an 8 out. So that is my output. Now, do I have an 8 as an input? Right over here? You betcha. And then the output that comes out is a 1. So my g of x would be a 1. And actually, this one's even easier to see the mapping because it just maps right across. I take an f of x. Again, I'm doing g of f of x here. And I take a 0, plug it in for f of x. I get a 13 out. Does 13 have a defined input over here? Indeed, it does. And then I get a 0 coming out, which is this 0 right here. So every one of the outputs from f of x has a defined input in g of x, and the output of g of x is exactly the same as what the original input was. So, you end up having, it's basically the same inverses rule. It works both ways. So it's kind of like we just did g of f of x and f of g of x. Now, let's spend more time coming over here to number 2. Let me erase all that stuff. So we'll do this one from scratch. I think I'll just leave this here. This is set notation, basically the defined input f of g of x in a set notation, so just so you know what that is. But let's do the same thing. We'll start with, let's do purple. We'll start with this thing and let's do it in purple. F of g of x. So again, easiest probably to look at that over in that table, and I'll create a f of g of x column over here. I take x, plug it into g of x, get a -4. And then I get, so I'll put a start here. And then this gave me the -4. Do I have a -4 defined in my f function as an input? Has to be an input. And then I go over here, and it's way down at the bottom. Now, notice right off the bat that I plugged 5 in, I got a -4 out. I map it over as an input into f of x. The -4 does have an input, but the output is -4 now. It is not the original 5. So I have a clue that this is not going to be an inverse. Okay, fine. Let's just go through the process here. 4 gave me a -3. -3 comes around, and it also has a defined input in the domain of the f of x function, and -3 will give me an 11. Okay, hunky-dory so far. Then I have a -1, which gives me a 2 output, and there's one more time. There's a 2 over here, and it has a -2 as an output. So good so far. Last point, I have a 2, which will give me an output value of 3, but oh no, I go over here and look over here. There is no 3 in the domain of the original function, so this is out of domain. Out of domain. It does not exist in my f of g of x function. So then the domain of f of g of this f, this is actually all, this stuff all goes down to the f of g of x function. The domain of it does not include the 2, because you can't go through this process, the composing process for the 2. The domain for it will only include 5, 4, and -1. I can put that in set notation, 5, 4, -1. I know we're used to interval notation for this, but these are only the specific values. It's not an equation, so it's not intervals or anything like that. It's just those 3 points. Likewise, the range of f of g of x, in this case, is the 3 values from here of -4 and 11 and -2. And if you write those out as coordinate pair, notice that you get back to the green that I had originally up here in the set notation. But okay, well, I'll leave it at that. Hopefully that's a little bit clearer now, and it helps. Okay, bye.